Last episode, we drew attention as a soft dictionary lookup, query times key, softmax, weighted values. Today, we stop drawing and write it. You'll see that the whole thing is about a dozen lines of PyTorch, and then you'll see the one line that replaces it in production. Here's the plan as code in order. 1. Multiply queries by keys, transpose to get the score grid. 2. Divide by the square root of the head size. 3. Mask the future. 4. Softmax each row. 5. Multiply by the values. 5 steps, 1 function. Let's write each one. The causal mask is the line people get wrong. We build an upper triangular mask, everything strictly above the diagonal, and fill those positions with negative infinity before softmax. Strictly above the diagonal means the future. The diagonal itself is the current token, which it's allowed to see. Get the offset wrong, and the model either peeks at the answer or can't see itself. Now the production reality. PyTorch gives you scaled dot product attention. One call that does all 5 steps for you and on a GPU fuses them into a single kernel. It picks the best backend automatically. Flash attention to the QUDNN kernel, a memory efficient path, or a plain math fallback, depending on your data type and your hardware. Why does the fused version matter so much? Because the handwritten one builds that full T by T grid in the GPU's slow memory. At long sequence lengths, that grid is enormous. The fused kernel never builds it. It streams the work in tiles through fast on-chip memory and keeps her running softmax. Same answer to within rounding, but the memory goes from growing with t squared down to linear in t. That's the difference between fitting a long context and running out of memory. Left is the code, right is the terminal. Watch the from scratch version build up line by line, then the one line replacement, then the proof they match. Set up random Q KV with the shape attention expects, batch heads sequence head dim, then the core scores equals Q times K transpose divided by root of dk. That single expression is the entire score grid. The terminal prints its shape, batch heads TT. The mask, torch true with diagonal one gives us the strictly upper triangle. Turn it to boolean. Masked fill drops negative infinity into those cells. Print one row before softmax and you can see the negative infinities sitting in the future positions. Softmax along the last dimension turns each row into weights that sum to 1. The terminal confirms a row sums to 1.0. Then weights times V gives the output shape batch heads T head dim. That's handwritten attention done. Now the fast path, f-scaled dot product attention of Q, K, V is causal equals true. One line. It auto-selects the best backend for your hardware. On a modern NVIDIA GPU, the flash attention kernel. And the proof, torch, all close of the manual output and the fused output, true. Same math, same answer, but the fused one never built the big grid. That's the exact operation TensorRT-LLM compiles and a name serves on every token for every user. Next episode, one head learns one kind of relationship, so why not run many? Multi-head attention, and then the trick that shrinks the memory it costs. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.